Okay, let's talk about displacement for now. Displacement is defined as the shortest distance covered in a specified direction. The shortest distance covered in a specified direction. Let's take another example. Let's take an example of a point. Let's say P, point P, 2 and 3, and we now say point Q, let's say 4 and 6. Now, if we should find their point in our axis, having here to be the coordinate and here the axis. So let's calibrate this 1, 2, 3, 4, 5, 6. The arrow direction indicating where it's going here 1, 2, 3, 4, 5, and 6. Now for the point, we have point P to be 2 for the abscissa against the ordinate being 3. So when we link this up, we end up having it at this point. So this will become at point P, which is 2 against 3 for the coordinates. Now for the second point Q, we have the abscissa to be 4, while the ordinate there is 6. So we'll link it up to this point and we start to where you have the 6. So we mark it Q and we call it the abscissa there is 4, while the ordinate is 6. At this point, remember that we said that the distance is actually the pathway between 2 points with regards to abscissa and then ordinate. But now, what we are talking about now is displacement. Displacement is the shortest distance between these 2 points. So if I should link out this is what I will have. But what we are referring to is displacement, which is the shortest distance from P to Q. So where do you think will be the shortest distance from P to Q in a specified direction? You agree with me that it will be the journey from here to this point, showing the arrow direction of where it is going. So with this, we end up having this diagram for it. Now, how can we now solve for this? We're going to use the Pythagoras theorem, since this is a right angle triangle. I remember that in your Pythagoras theorem, it says that the square of the hypotenuse is equal to the sum of the square of the two opposite sides. Let's call this P, Q, and let's call here point O. So the square of the hypotenuse that will be the PQ square is equal to the sum of the squares of the two opposite sides, which is my PO plus OQ squared. So at this very point, what is my PO? The PO there is the change in abscissa squared. Then while the OQ is the change in the ordinate, which is change in y-axis. So the change in x will end up giving me the highest value here, which is x2 minus x1, plus the y2, the y change in y, which is y2 minus y1. With this, what we are going to have here is that the highest value of x here is 4, while the least value of x here is 2. You square it, and you go to the y-axis. The highest value for the y-axis here is 6, while the least value for the x-axis here is 3. You square it. 4 minus 2 will give me 2 squared, plus 6 minus 3 will give me 3 squared. 2 squared will give me 4, while the square of 3 will give me what? 9. So at this point, 4 plus 9 will give me what? 13. So this is the value for PQ squared. So if you want to look for the value for PQ, this is supposed to give me something like 3.36 approximately meters.